we will summarize all this information. So let's take it step by step. So my function will be defined everywhere with the given conditions, of course. F of 0 is 3. That's the easiest thing. The limit of f of x as x approaches 0 from the left, parenthesis, 0 from the left, is 4. Done and done. The limit of f of x as x approaches 0 from the right, parenthesis, is 2. Done. What does this mean, really? The function exists at 0, and the limit from the left is 4, and the limit from the right is 2. So I summarize my information so far. Moving on. Limit of f of x as x approaches negative infinity is negative infinity. Okay, done. Now they're talking about 4. Okay, fine. The limit of f of x as x approaches 4 from the left, 4 from the left, is negative infinity, a parenthesis. Done. It's in my table. 4 from the right, another parenthesis, it's infinity. Done. This is clearly telling me x equals 4 is what?
Vertical asymptote.
Perfect. Thank you very much. And now they say the limit of f of x as x approaches infinity is 3. What does that mean?
Horizontal asymptote.
That's it. See, we already made sense of all this gibberish by simply putting it in the table. So here's my graph. I will definitely start with the points that I have and whatever I have. So let me know if this color is not visible. So I have 0 is 3. And this is a full point. 0, 4 is not a full point. 0, 2 is not a full point. So I already took care of this piece. At 4, 1, 2, 3, 4, I have to show the vertical asymptote. Okay. It says from the left of 4, negative infinity. Okay. So I could show this. Then there is a horizontal asymptote at 3. Oops, y equals 3. So from positive infinity on the right-hand side, it drops to 3. From positive infinity, it drops to 3. Okay, so I have this side. I don't have this side yet. Well, now I do. So let's see. The function is coming from negative infinity. Any function can cross a horizontal asymptote. It can never cross a vertical asymptote. It can even cross a slant asymptote. Okay, so that is allowed, but not a vertical. So from negative infinity to 4, okay. 0, 3, okay. On this side to 2, so from 0, 2, which is open, coming down to negative infinity, it has a vertical asymptote. And on this side, it's coming from positive infinity, approaching 3. This is my example of f of x. You can find multiple examples. You can add whatever else you want, but you cannot change what it's given, but you can add. If you want, you can add a vertical asymptote here. You can add anything you want, as long as all the given conditions are fulfilled. Any questions on this problem? Extremely important to understand this because we are going to add 2 more rows to this table very soon. I don't have anything else to say about chapter 2, unless you have any questions about chapter 2. So the options are, we can have the test a week from today. We can review for the rest of the half an hour today and about an hour on Tuesday. But allow me the second hour to start because spring break is coming up and we have to have test 2. Which option works best for you? And let's make a decision.
I like having the test on Thursday.
Okay. Test 1 Thursday, March 3rd.
Let me look for you.
I think so. I have it right here. March 3rd. And Tuesday, 1 hour for the review and 1 hour for chapter 3, which is not on this test, but I have to start. There are 3 weeks left. Yes.
I was just going to ask, what do you think would be a good way to study for the test?
Yes. So what I would do, I will redo the notes, the class notes. If a problem was not presented in class, I would not put it on the test. So that's the first thing I would do. And I will go to the videos only for the problems I need to look at. So this would be my first suggestion. You have to finish up, which page am I on? 6. You have to finish up all WebAssign from chapter 2 with at least 60% in order to take test 1. I will open them again after test 1 and you can raise your grade if you want, but minimum an F on the homework to qualify to take test 1, please. Okay, other questions? Other questions? Okay, then I'm going to choose some problems for us to work on.
I have a question.
Yes?
So how many questions are going to be there in the test, and
About
how long is it going to be?
You have 2 hours for the test. I always allow 2 hours for thank you so much. I always allow 2 hours for the test. And you will have somewhere between 12 and 14 questions, and some of them may have part A, B, and C. And how we conduct the test, I will remind you again on Tuesday. Other questions for me? Very good question. Thank you. Anything else?
I don't have a particular question,
yes?
but I wanted if we could go back over 2.4.
Yes.
Just
yes. In 2.4, there are many options, but I only presented one. I did not show the precise definition for anything that is squared. I did not show the precise definition for anything that, I'm sorry, I didn't mean that. Anything that has infinity as the answer. So I am only happy with presenting the limit as x approaches 1 from 1/2 minus 3x. So how much is this? 1 minus 3, negative 5/2. So that's it. Okay, so that will be only for a linear function. No quadratic, no infinite limits. I'm happy if you just remember this as a puzzle, really. So for every epsilon positive, I will find a delta positive such that 0 less than the absolute value of x minus 1. Of course, less than delta will always imply 1/2 minus 3x plus 5/2 less than epsilon. And you know what this all means. Make this look like this. That's all it is. So manipulate this within the allowed procedure to look like that. Once you make this one look like this, in other words, what? X minus 1 on the left-hand side, and whatever you get on the other side will be delta. That's all it is. Okay? So our first step, of course, I have to find the least common denominator. So I have 1 minus 6x plus 5 in absolute value less than epsilon. Then I have negative 6x plus 6 over 2 in absolute value less than epsilon. Do not skip any step. You have to factor out negative 6 at the top. You see, it already is getting into shape. Make sure that you don't divide by negative 6. That will be a tragedy. Remember, delta has to be positive. Epsilon is positive. At the end of the day here, if somebody writes that, I'm sorry, that delta equals negative 3 epsilon, I can't even look at that. Because I've had it. I've seen it. I've had it in students' papers. So please do not ever write something like this. Because delta is positive. Epsilon is positive. So if you write delta equals negative 3 epsilon, then I know that something is terribly wrong. And you can't do that, right? Okay, so move on. You have from here, you have to write the following step. The absolute value of negative 6, the absolute value of x minus 1 over the absolute value of 2 less than epsilon. This step has to follow. You cannot move on and say, oh, but I'm multiplying by blah, blah, blah. You cannot do that. This step has to be there for full credit, please. Okay, now, yes, I will write that the absolute value of negative 6 is indeed 6. And x minus 1, and then 2. Because the absolute value of 2 is 2, and then less than epsilon. And yes, I will simplify. And yes, now I can divide both sides by 3. And this is done. And I know that this must be, I compare those two, this must be delta. So if you omit this step and you come up with a negative delta, that will be telling me that something is not right. The understanding is not there.
On the test, in order to get full credit, do we have to write, we have to reverse these steps to prove it right?
Yes, that was number 2 that I was going to write. So show that delta equals epsilon over 3 works by reversing the steps. Yep. Just one sentence. You don't have to actually do it. Good question. Anything else you have on your mind? Or I can choose other problems to work on. So please remember this step has to be there. Please. Okay, anything else? Anything else you have on your mind?
So I know this isn't, I guess it's just a general question. I know we've done some examples with some small bit of trig in them, so could we expect trig to be on the test?
Yes, so let's take a look at some trig. Here's an example. So we're asked to find this limit. And then I would like to look at the limit of natural log of sine x as x approaches 0, as approaches pi from the left. Okay, so later on, I will not forget. If I forget, please remind me. Okay, so looking at this, what do you think? What memory does this bring?
The squeeze theorem.
Excellent, brilliant. Thank you, Katie. Indeed. Because we're really talking about a bounded function. Cosine 1 over x squared is between what and what? Because this is 0 and this does not exist.
Negative 1 and 1.
Yes. And you could say, but 0 times d and e, come on. Isn't that 0? Not necessarily. Okay, perfect. So I have this piece built in here. But this is not the function. This is the function. What should I do now?
Multiply all 3 by x squared.
That's it. Because this is positive and it's not 0. How do I know? Because this really means not equal 0. Why is this important? Because if I have x cubed, this could be negative, right? So then when do I switch the symbols and when I don't? So, but this is okay. I'm safe. X squared is positive and it's not 0. Excellent. So negative x squared less than or equal to x squared cosine 1 over x squared less than or equal to x squared. Perfect. So now this is step 1 of the squeeze theorem, in which this function is f of x and this function is g of x. So we show that it's squeezed. Negative x squared here and x squared here. Good. What is the second step of the squeeze theorem?
Finding the limits for the 2 outside functions.
Excellent. So the limit of negative x squared and the limit of x squared, of course, when x approaches 0. What are these?
Positive infinity.
One more time. That would be a tragedy, because then the squeeze theorem is not applicable.
Oh, yeah.
Maybe just 0.
That's it. So when x approaches 0, the limit of negative x squared is 0. As x approaches 0, the limit of x squared is 0. From 1 and 2, by the squeeze theorem, what do we conclude about the limit of x squared cosine 1 over x squared as x approaches 0? From this and from this.
H of x equals 0.
That's it. The limit is 0. Not h of x, but the limit is 0. Awesome. Great job. Now I want to talk about this one.
One more thing, please. I'm sorry. I was wondering, how did the negative 1 become a negative x squared?
Say that again. I couldn't hear you.
How did the negative 1 become a negative x squared? On the
I have to multiply everything. I cannot pick and choose.
okay.
I have to multiply this by x squared. I have to multiply this by x squared. I have to multiply this by x squared.
Got it. Thank you.
Better? Very good. Okay, so we had that limit of natural log of sine x as x approaches pi from the left. Okay, so pi from the left. I keep losing my props. Oh no, I found my prop. Okay, so whenever we are given a limit, that's our starting point. We have to plug it in. So now, can anyone tell us where this is going? We always have to start from the inner function when we evaluate something. So as x approaches pi from the left, so pi from the left is somewhere here. Pi from the right is with numbers larger than pi. Pi from the left is with numbers, in this case angles, smaller than pi. This is pi. So where is sine from the left of pi going to? Remember, sine is measured on the y-axis.
Zero.
Excellent. Stay with me. But of course, 0 from the right with positive values, right? Because sine will be negative here. Good. So now let's think about this. Natural log from the right-hand side of 0. I don't know. Let's graph the function. This is natural log x. So where is this going?
Negative infinity.
That's it. Which means that x equals pi for this function represents what? Because the answer is this.
Vertical asymptote.
Thank you very much. Thank you, Sarah. Okay, here's another one that I would like to look at. Limit of tangent inverse. I don't like this notation. I'm going to change it right now. Any questions before we continue?